Now let's see the concept called as total order relations. So totally ordered means if you have a set and a relation on that, and if you take any pair of elements from the set, if those two participate in the relation somehow, then it is called as totally ordered. So what I mean to say is, if you have a relation capital A or a set capital A like this, and if you have a relation capital R, then it is called as totally ordered set if every pair of elements in capital A, which means you take any two elements in capital A, they are comparable, which means either if A comma B belongs to capital A, either A comma B should be present in the relation or B comma A should be present in the relation. For every pair, if this is happening, then we can say that it is total ordered. With some examples, I'll explain you. See this? Check whether the following are totally ordered relations or not. If capital A is set of real numbers, then the poset A less than or equal to. What can you say about it? That is what they are asking. So, if you have set of all real numbers, can you take any two real numbers and can you apply the relation less than or equal to between them or not? Yes, we can apply, isn't it? If you take 1 comma 2, then I can say that 1 is less than or equal to 2. If I take, let's say 4 comma 2, then I can apply 2 is less than or equal to 4, which means take any two numbers, we can apply the relation between them. Therefore, every two relations are related, every two elements are related. That is why we can say that it is a total ordered set. Now sometimes it is also called as linearly ordered set or chain. So why is it called a chain is, later when I show you something called as Hussey diagram, we'll put this poset in a Hussey diagram form, which means I'll put all the elements like this, number 1, number 2 like this, and 1 is less than 2, 2 is less than 3, 3 is less than 4. So if we have a total ordered set, then it will just look like a chain. So you might not understand this concept now. Later when we discuss about Hussey diagram, I'll make this point clear there. Okay, till then you just forget about it. Again we get back to the chain when we go to the Hussey diagrams. Okay, next one. So just now, for now, remember that every total ordered relation or total ordered set is also called as a chain. Now see this, if A is having 1, 2, 3 so on 10, then the poset A less than or equal to is dash. Now when we take any two numbers of this set, can we apply less than or equal to between them? Of course we can apply it, isn't it? See, if I take 1 comma 10, yes, I can apply. If I take 1 comma 2, I can apply. 1 comma 3, I can apply. 3 comma 2, I can apply. 3 comma 5, I can apply. Take any pair, we can apply it. Therefore, it is also totally ordered set. Now, just out of curiosity, if I replace this less than or equal to relation with divides, let us say this relation is defined by A comma B belongs to the relation if A divides B, like that. Now, is that a total ordered set? See this, 1 divides 2, 1 divides 3, so on 1 divides 10. Therefore, 1 is comparable with every element. But will 2 divides 3? It is not possible. Therefore, 2 comma 3 are not related, because 2 does not divide 3 or 3 does not divide 2. Therefore, these two are not related. Every pair has to be related, then only we can say that it is totally ordered. Therefore, what can we say? In case if this is divides, then it is not a totally ordered set. Earlier it was less than or equal to, therefore it was totally ordered set. Now see this one. A is containing this, then A comma divides is the relation. So what can you say about it? Can you take any two elements in this and can you say one number divides the other number? See this, it is possible here. 1 divides 2, 6, 30, 60, 300. 1 divides everything, right? And similarly 2 divides 6, 30, 60, 300. And similarly 6 divides 30, 60, 300. 30 divides 60, 300. 60 divides 300. Therefore, every two numbers are related, which means we can take any two numbers and we can put the divides in between them. Therefore, we can say that it is a totally ordered set. Now, if you take this one, it is a set. It is a set of sets. Now, if you take subset relation on this set of sets, is it totally ordered set or not. Now can you take any two sets and can you apply this inclusion relation between them? For example, I can say that phi is a subset of A, phi is a subset of B, phi is a subset of AB. Fine, phi is comparable with every other element. What about A? Is A subset of B? No. Therefore, these two cannot be compared. A is not a subset of B or B is not a subset of A. So they both cannot be compared in any way using this subset or proper inclusion relation. Therefore, we can say that it is not total ordered set. Got it? And now let's see this one. If S is containing phi and all like this, if S is a set of all sets, then what can we say about S comma less than or equal to the poset this one? So sorry, it is not less than or equal, it is subset, proper inclusion. Now you can see this, phi is subset of A, phi is subset of AB, phi is subset of ABC. Therefore, phi is comparable with every other element in this set. Similarly, A is subset of A is subset of ABC. Therefore, A is comparable with every other element. And similarly, AB is subset of ABC. Therefore, it is also comparable with every other element. So, we can say that since every element is comparable with every other element, or every pair of elements can be comparable, we can say that it is totally ordered set. Got it? So we can see more about this later when I discuss about Hussey diagrams. For now, since we are going in a sequence, let's keep this topic here and you just read about it now. Later I'll again get back to this. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.